Hi, my name is Saqib Aziz. You're watching Rhinoceros and Grasshopper tutorials. In this tutorial, we will look how to model up a spiral staircase in Rhinoceros. Currently, I am in my rendered view. So this is the staircase we want to model up. And we'll look at how to create these solid parts, which is a little bit filleted at the end, just to give it a little more detail. Then we will look at how to generate this glass balustrade with a profile, handrail basically, and using different kind of logics, and I want to just dive into it basically. So what I'm going to do, I'm just going to take this guy and move it away, let's say somewhere that I don't see it anymore, and we will look at it later and just compare what we did with the one that I just showed you. So we will just start from a fresh canvas, let's say. So I'm going to go into my top view, and the first thing I want to do basically is going to say I want to just mark my origin point, and I'm going to do that with a point. So I'm just going to type in point and just type in 0, and this is going to mark my origin point. This is just for us as a location point, and I'm going to lock it so I don't select it anymore. Okay, so now I'm going to go into my layer tab, and I already did it here, but I'm just going to do it again. So I want to do a new layer, and I'm going to call this one line work. And this is going to be our layer where we put all our line work that we don't need later on for the geometry, but that just helps us to draw the geometry itself. And then we can just create maybe a layer called solids. I already have a layer called solids, so I'm just going to keep this 0.2 and just type in solid again. And then we can have a layer for, let's say, glass. So top view, origin point is drawn, and the first thing we're going to do is type in circle and generate a circle. Now I'm going to type in 0 for my origin point, and then I want to say enter, and now I can define my circle by a radius, and the given radius in this example is going to be 1.5 meters. You can type in anything you want, but in this case I'm going to just use these values. And now I want to offset this circle by, let's say, 1 exactly, 1 meter. So I have to type in offset, and then I have to type in, I'll just type in 1, and that should already do the trick. And you want to offset inwards. And why I did that is simply because this is going to be the width of our stairs. So this is basically going to be 1 meter in width. That ensures that you can actually walk the stairs. This is fine, and now I want to actually divide these two curves because I just want to generate one stepping, which I'm going to use later for my polar array, or array polar. And I want to divide it basically, and I'm going to show you two different methods how you could do that. So the first thing is to actually just select these two curves and say divide. And you can then first you can see where your seams are and in which direction they're heading. So right now my seams are all perfectly fine, aligned with the x-axis here, and they are oriented in such a way that they're going to flow anti-clockwise. Yeah, I could change that simply by just clicking on these arrows, and they would change the direction, and now they're going clockwise. It doesn't really matter for this example, but always keep in mind it always depends if you're dividing a curve where the seam is going to determine where those points will start to divide, yeah, and the direction is going to determine in which direction they're going to flow basically. That's very important if you divide anything by length, and because that gives you in the end of the curve is not going to be the length that you wanted it to be. So always keep that in mind that you determine that. Okay, but in this case it looks fine. You're going to press OK, and now the first thing I want to do is I want to say mark ends, yes, okay? And the number of segments is going to be 15 in this case. So I can type in 15, I already have it as a default, but I'm going to just type in 15, and that should generate these points. So I have just divided the two curves, or basically I've marked the division points because the curve is still intact, right? I just marked it to visualize where I'm going to divide it now, okay? So there are two different ways to do that. I could now either just draw lines here connecting the points that I want to have, select this guy, and then basically split, call the split command, select objects to split. This is going to be my circle. I press enter, And then the cutting objects are the two curves that I just generated using a line command, press enter, and now I have basically these splitted from the rest of the circle, the segments, and I could go along and just join them. And then I have my first stair, basically my 2D representation of my first stepping. There's another way to do that. If I just go back and go one more back, so the circles are still intact. Yeah, I have marked those points. But what I could do also with the divide command is if I type in divide again, I select these two curves, and this time I'm going to say, yeah, it's perfect. Drag seam is still okay. This time I'm going to say split yes, and 15 is still going to be there, and you can see there's no more options that I can enter. So I'm going to continue and say split yes. This time what will happen is I'm going to split everything that I want, that I gave it basically with a determination of 15 segments. It's going to split it for me. So the circles are splitted. So there's just like two different ways, workflows to do that actually. It doesn't really matter right now because the one thing that we want to have is basically just this one stepping. So I'm going to say cell PT, which will be the shortcut to select all the points, and I'm going to delete them. Because I don't need it anymore. And now I'm going to say cell curve. Sorry, cell curve. And just going to keep them by pressing the control button. Just going to keep them that I want, which are these four, and the rest I'm going to delete. And this one I can just join, and I have now one closed curve, which is planar. And I can now switch into my perspective view. There are different ways to do that. You can just go here on the lower end of the interface and go to perspective. You could just go here on the overview just by double clicking on this perspective annotation, and then basically the header, and just switch it into any scene you want to be. So perspective is the one that I want to be right now. Okay, so we generated this guiding curve, and now we want to use a polar array or array polar to actually generate this spiral form and use the steps as the guiding geometry for that. So I'm going to say array, and you see all the array commands that you have, and we're just going to use array polar. Select the object that we want to array, is going to be our curve that we just generated. Say enter. Axis, or the center, is going to be 0. You can either select our point or just type in 0. The number of items is going to be 15 because we divided the circle into 15 segments, and we want to keep that logic for a full rotation, right? Because that's how we define the geometry. So 15 is fine. And now I'm just going to make sure of that I have a full rotation, 360. That's fine right now. If you don't have it, please type in 360. And what I want to do as well is say my Z offset is going to determine the stepping in the Z direction. So this is going to be my height of my steps. And there are different values you can draw upon. And I think in German standard there's this value of 27.5. But just for the sake of it, we're going to take some value that is a little bit easier to remember, which is going to be 25. So in my Z offset, if I press on that, I can just type in 0.25 and press enter. And basically now I can break out of it just by pressing enter 2 more times. You could have a preview if you could see it right now. Don't matter. If you press enter again, you will see that we actually have our spirals now. We have 15 closed curves, all in a or in a full rotation of 360. And if you go into top, we can see that it's actually, you can't see that it's 3-dimensional, which is always a good sign. So there's no overlapping, and this is totally fine. So I want to be a little bit efficient here. So I want to not always have to select each curve individually. So that's why I'm going to say cell curve. It's going to select all the curves that I've drawn so far. Make sure that you don't have any other curves there, because I want to group them now. So I'm just going to type in group, and that will just group these 15 curves into one group. So every time I select just any curve of my choosing, it will have the full group. Now remember, you can always access one of those curves if they're still in the group if you press Control and the tab, or the Shift, sorry, and you can basically get one of those. If I don't do that, you will have the full group. Perfect. Now we want to actually generate the steps, the solid parts basically of our first geometry, which is going to be solid. So select those curves and say extrude curve. And we want to have the same logic here. So we will type in 0.25. And this is going to generate our steps. So there you go. This is how it should look so far. If you have done that, that's perfect. And now we want to use two different commands which have the same output, but just so that we can understand that. We want to draw the guiding curve of our balustrade, and basically two curves which are going to be a spiral that spiral up from the lowest point of our stairs to the highest point. Yeah. And I'm first going to do it with a helix command, and then I'm going to do it with a spiral command. So you just have used both, and you understand a little bit the logic and the difference of these two commands. So the first thing I want to do is I want to draw a helix, and that's what I'm going to just type in helix. So I want to draw a helix that's, like I said, going from the lowest part to the highest part. That means my helix has to go vertical, right? So the first thing I do before I do anything here is that I'm going to say my start of my axis is vertical. I could do that by either typing in vertical or just selecting vertical here, or I type in V as a shortcut, press enter, and it's vertical. Basically, vertical is locked. Then the start of my axis is always going to be here in this tutorial, is going to be the origin. Again, I could just hover over my point that I defined before and I have locked, or I just type in 0, because that's, I think, a little bit more faster if you know where your starting point is. Just type in 0, and now you can see in this cyan color that my start is basically the origin. It's going upwards in the Z direction, all fine. And now I just have to determine the overall length or the height, and I can do this by just catching the highest point of my stairs, which is going to be this guy here. So the highest corner of my solid part here. And in order to catch it, if it's not working for you right now, just make sure that you have your O-snap on and that you have at least the end checked. Otherwise, it's going to be difficult. Yeah? So having that said, I'm going to just select the height. And now I have to determine my helix. And just to make it a little bit shorter here, just make sure that it's diameter right now and you're not using radius. You can do either way. You just have to understand what you're doing. Mode is right now in turns, and I have one turn because I'm gonna need just one turn, 1 360 turn. If I do 2 turns, then it's going to be difficult to draw the balustrade because it's a little bit weird, the geometry then, right? So I'm just going to do 1 turn, and now it doesn't really matter where you actually define it. You can define it in the lower part or in the higher part. I'm just going to use the lower part because it's easier to illustrate. So I'm going to take the most outer point of this stair and just going to draw a spiral now, a helix. And you can see what it did. Basically, it generated this curve that is a helix, and just determining or binding this and being the first instance for my balustrade later on. And every other geometry modification I'm going to do afterwards. So you could do the same thing with the spiral, and that's what we're going to do for the outer point, which is going to be this point here. Same logic. We want to connect this point with that point using a spiral or helix geometry. The difference between the helix and the spiral is that spiral has one more function or one more step that you have to go along. So if I call spiral, it's the same thing. The first thing you want to do is determine what kind of geometry you want to draw. Is it going to be flat, just a 2D representation? Is it going to be vertical or around a curve? I'm just going to type vertical, V, shortcut, axis, starting point, 0. And now again, I have to determine the height. It's going to be the same height. Same thing, diameter, mode, turn, 1. And now I have to determine my first radius, which is going to be the outer point here on my stairs. And now see, the difference is before, if I just with the helix, if I just had determined this point, it would be finished now. We already have drawn the helix with a perfect catching of the endpoint here. Now with the spiral, I can still more or less determine the second radius. So I could potentially do it higher if my geometry would want that to be. But in this case, the geometry does not want that to be. So I'm just going to have to define the second radius to be the outer point of the highest stepping. Yeah. And you see, I didn't catch it right, so I have to do it again. So that's why I used this helix before, because in this case, the helix works just fine using one less step. But I'm going to try my best again. So I'm going to catch this guy and really make sure that I catch it, and now it's fine. Yeah, that was just my mistake of me being messy. Okay, so we have generated this logic, which is totally fine. And now we want to actually do two things shortly, so we can continue on. I would just want to group these guys right now, just for the sake of it. So I'm gonna select my solids, so cell solid. That will select my solids. And I'm just gonna group them, just to make my life easier. What we want to do now is to basically trim off this sides here. So we don't want to have the lower solids that's lower than my curve here. And the way that I want to do is basically use a Boolean command, Boolean split. And sometimes the Boolean split is really sensitive in regards to what you have drawn as a geometry. So if you want to use a loft, basically a surface to trim off solids, you really want to make sure that your loft is not really tight on the solids in order to understand that it wants to be a Boolean split. So I think I'm just going to show it to you or demonstrate it to you. I think it's going to be easier to understand. So what I want to do is basically, I just don't want to have my curve so tight on the solids. I just want to give it a little more space and do an offset basically of 0.5, so 5 centimeters, and always upwards. Yeah. And the same thing I'm going to do with the one here. I'm just going to make sure that it goes this time outwards. Outwards in this case is going to be facing to my origin point. And now I've generated these two offsets. And again, this is going to be helpful for my balustrade. So my balustrade here on both sides is going to be 5 centimeters. And also what's going to help me now is that I can select these offsetted curves. And I'm just going to loft them. Say enter. And I'm just going to trim it now, basically. I want to just generate a trimmed solids. So what I'm going to call upon is going to be Boolean split. If you type in Boolean, you'll have different Booleans, and you want to use Boolean split. So the first thing it's going to ask me is going to say select surfaces to split, and these are going to be my solids. And if I press a solid, it's not grouped anymore in this command, because if I go into the command, it will ask me to select all the solids that I want to split individually. I don't want to do that. I'm just going to say cell solid. That should select all the solids that I want to trim. Just make sure that all the solids that you have currently on your canvas are the ones that you want to trim off. If there are more geometry flying around, just disable them. Yeah? Just press Control and then deselect them, because otherwise the command will have some not even problems, but you just want to be clean with your line of command and line of thought there. Okay, so I press enter, and then it wants to have a cutting object or cutting surface. This is going to be our loft that we just created, and now hopefully it should have worked. Yeah, so I still have my grouped command off, so I select my solids and I say ungroup. And I can see that I have 30 poly surfaces, which is a good sign, because I had 15 solids beforehand, and now I have twice as much, which means that my split has functioned. And basically now you will understand what I said. So what it did, it splitted the solids that I had before using the surface here. So everything that's below the surface, I can now just delete. I don't need that anymore, because that was just in the beginning. And we will continue in a slightly different way. So I'm just going to delete these guys, and I have a clean Boolean split. And now what I could do basically is I will take the surface, I think that's the best way, and just use extrude surface. And just want to give this whole thing a little bit flesh, because right now how it was looking was very, you couldn't build it like that. So I'm just gonna give it a little bit flesh, and this is something that you can define yourself. I'm gonna type in 0.2, which will result in 20 centimeters, and I think that looks pretty much okay-ish. I mean, of course, this is not super realistic, yeah, you couldn't build it like this, but just as a starting point, this is okay, I think, yeah, so you get the idea. You have basically the same logic. You have these steps which have all the same geometric attributes, basically that they are splitted from their corner points to the corner points, and then you've always like 20 centimeters more or less of flesh that you give it below. Okay, so we have a different scenario here on the lower part, because our lofted extruded surface went below our origin point, let's say. So we can just trim that, and I'm going to use a method, and my gumball is activated for this, yeah. So I draw a line just somewhere. It should be parallel to my lowest step here. I use my gumball is on. Rhino 6 has this function that you can just extrude your geometry. I'm going to deselect my line, select the surface, and push it down. Okay. If you have Rhino 5, you can just take that guy, extrude curve, extrude it. If it's going downwards, you have to say direction. You have to define the direction. My ortho is on. That helps me to draw along those axes. Then I can just go along the y-axis, determine my surface, and then I'm going to do a extrude surface and just go downwards and have the same result. Yeah, so different methods. You saw that in using the gumball, you're just more fast. So now I just want to say Boolean difference this time. I just want to trim off the solid here, this guy, and you see the intersection part here is going to be deleted now. That's what I want to do. So I press enter, and the point surface to subtract with is going to be my box here, and this is going to give me this clean detail here at the end. So far so good. Now what we could do basically is continue on with our logic. And for that, I'm just going to say cell curve for a second and just say hide. I don't want to see it right now, but it's still there. Just doesn't see it now. I don't see it now. I'm going to select the surface, delete it, and just want to look at this for a moment and see how we could make this a little bit more prettier. So what we have is already a quite, it's quite, you know, flowy in a sense. The geometry is already a little bit like really elegant, and it flows in the spiral shape. So, and then we have this solid part, which is still a little bulky and very orthogonal. So what we could use is basically a method of filleting or chamfering, or a different method called, let me see, if you go to solids, you go to fillet edge, you could say fillet edge, you could say blend edge and chamfer edge. Basically slightly different arrangements, but for this one I want to use blend edge, and I want to blend these edges here, and I have to say, first of all, select the surface or the edge that I want to blend, and right now it's set it at 1 meter, which is extremely, is too much, yeah, because my geometry is limited to 20 centimeters, and everything that is higher than that will result in a weird shape. So I want to say 0.1 and try if that is going to work. Say that, and I have to break out of that because sometimes there's this thing that I didn't really select it good. So I'm going to do the same command again, just bringing it back. And now from the get-go, my next radius is already set to 1.0 because it remembers what I did the last time. And now it should be easier to do that. There's a slight bug, or it's basically just me not understanding the command right. But if it happens to you, this is how you could just solve it. Just break out of the command because it will remember what you did as the last radius, and just go into the command again, and then basically with the 0.1 blend value, we can now blend our surface here, and that will result in this very nice, this little bit rounded shape of our landing, of our solid landing. And the same thing we will do at the inner edge. So the same command, I'm just going to access it again. So blend edge, select the edge, next radius is by 0.1. It will always show you this preview here. You could actually change it even. You could just take these handles and change it if you wanted it to be. And you just press enter and you should be good to go. Okay, so that's basically how we did that. If you go into rendered, you can already see that we are pretty close. We are almost actually there. Now we want to do the balustrades. And we want to extract isocurves of this surface here. Why do we want to do that? Because we want to have a spiral showing the central line that is going upwards along the surface between this and this point. So if I would draw a line from this point to that point, basically these 5 centimeters, right, of our balustrade, I would have the middle point. I can mark that with a point. I have my O-snap, my mid is on. I will mark this guy here, and I will do the same thing. I just copy and paste, copy this guy to that guy. Okay, and now I want to do, I'll just show you this command, which is called extract isocurve here, and for that I have to select the surface. Now this is a poly surface, right? But if I'm executing this command, it understands that, okay, if I select this whole guy, he just maybe means this surface here. So it just selected this surface here, and now I can extract any isocurve on that surface, as you can already see here in the preview. And right now I have my direction is U. I could change that. I could say both, for instance, if I want to mark one specific point. And as you can see, if I go along here, you have these two lines, these two curves, which are always on the surface, and you can extract them. So that's basically why it's called extract isocurve. But in this case, I want to only use the V direction, yeah? So I just have my V toggled, and that will allow me to extract a curve which is always on the surface at any given point on my surface. So in this point, in this way, or in this logic, I already marked those 2 points where I want to actually extract the isocurve, and I have my points here, so I can just select them, and it's still in the command. And as soon as I'm finished, I can just press enter, and I extracted those isocurves. Okay, so this was a little bit complicated. We could have drawn helixes again. That should work exactly the same way, but the helix only works if it's really a helix, right? If your geometry is something else, you have to have different methods of how to extract some points or curves on that surface, and extract isocurve is the best way to do that. So no matter what shape your surface is, if you want to have a specific curve or isocurve extracted, you do it in the set way. Okay, so now we could simply just take this curve, these 2 curves, say extrude curve, and put it upwards, let's say by 1, and we would be good to go. No? That is something we would think would happen. But the way that we did this right now is slightly not really doing that what we want, because we have a slight different output. So if I take distance and I actually measure the distance at the highest point, it's going to be 1 meter. And if I now look at what I have here, now actually the lower point of my stairs is going to be, so it's going to be counted from the lower point to this point. It's going to be 1 meter, and here it is different because here's the highest point to that point is 1 meter. So we need to somehow bridge that gap, yeah? So I'm going to just delete that for now, and I'm going to generate 2 curves which will determine that. So I'm just going to press line to vertical, and now I want to actually have a line here which will take the 25 centimeters of that stairs plus 1. So I'm going to type in 1.25, and I have that curve here. And here I'm going to just do a line which is 1 meter. So line vertical V, yes. Select the point and type in 1. And now I'm just going to select that curve, copy that guy. Again, I mean, this is not super accurate, and this is maybe potentially even wrong, but it's still, if you want to just make sure that you understand your geometry better, just want to show that basically to you. So now what we did is basically make sure that every time you're on the upper side of your step, the distance to the balustrade is always going to be 1. Yeah, in this case, so my upper point here is, and to the upper point of my balustrade is going to be 1 here, and here it's the same thing. So the upper side of my step to this to this point is going to be 1 meter. And now I can just use helix again, actually, and it's going to be slightly different, but vertical is still the way that I want to access the information, but my starting point is not going to be the origin anymore. It's going to be this guy, actually. Yeah? But still, the start of my axis is going to be determined by the origin point location, so I have to somehow trigger this intersection. Yeah? So the way that I can do that is just type in line, use your ortho to have a straight line to the X, you lock it, and you go to your origin point, and this way you have your new point here, which is basically this point, or you just take that point, you say unlock, you take that point, you make a copy, you say copy, you say vertical, and you say 1.25. Yeah, it's just different ways to do that. Sorry, I did one more copy pressing there. Okay, so now I can do helix again, say vertical, define my origin point now. It's going to be this guy. The height is now the upper point of my lines that I draw before, and now turn 1, and now I'm just going to do my helix here and do the same thing, vertical, my origin point is here, my height is this guy, and actually let's catch this guy now, and now we have our balustrades. Looking good. We can delete this information, we don't need that anymore. And now what we could do, basically, we can delete this guy here, this guy, this guy, and this guy, and we can just loft our new created helixes with our extract curve. Extracted isocurve. So I have these two guys selected, and I just type in loft, and that will result in my nice balustrade loft. I can do that again here, and I can just press a loft, and I have what I wanted there. Okay, we are almost there actually. Of course, there are some tweaks I can still show you, but the one thing that I really want to do before we continue is to a thickness. Yeah, the surface has to be thick because glass is not paper thin. So I'm gonna just do extrude, or let's say offset surface. It's a little bit different. Offset surface, and we want to make sure that our solid is set to yes, and the distance is going to be 0.025. I have that already set, but I can type it again, 0.025. So basically the equivalent of 2 centimeters, 2.5 centimeters, sorry. And before I press enter, I want to make sure that my facing of my normals is outwards. So I just press on the geometry, and that will just shuffle my arrows, and the arrows will indicate where my surface is going to be extruded at. So if this is my surface, my normals are showing that way, that means my surface is going to extrude that way. No, it's not double both sides, it's going to be one side. This will be started, the normals, and that's how it will extrude. So that's fine. We press enter, and now we should have our extruded balustrade there, and we have a slight gap for any lighting or garbage cleaning methods. And then again, this way we do this geometry, we do the same trick. We have the normals facing inwards, outwards, and the distance the same. Press enter, and we are good to go. I'm going to select these two guys, put it on the glass layer and color the glass layer with cyan so we see that it's different, and then everything that is here, I'm going to go to the materials. I'm going to set the default to glass, okay. And this way, if I go to my solid now on my rendered view, it will always understand this is glass. And we're almost there. So 2 more things I want to do. So the first thing that I want to show you now is going to be how to actually draw the profile, so that we have a metal profile, let's say, at the upper part of the glass balustrade, in order to just make sure that the glass doesn't break or it gets splitters. So the first thing we need to do is understand our profile here. It's going to be like we did before, so 2.5 centimeters. And we can use that information to draw a profile ourselves, yeah? So this is what we're going to do now. We're going to switch into top, and at some location, anywhere you want, you go here and you do project, so everything is nice and flat on the projected plane. Now we're going to draw the profile. So basically I'm going to use a polyline and just going to use that to say, okay, I want to give this guy 1 centimeter. I'm going to go up by 2 centimeters. Going to go again by 2.5. That's going to be the width actually of our profile of our glass. And then I'm going to go back 1.1 and undo a U. If you have done something wrong, you go up, let's say we go 3 centimeters. And we just close that guy. This is going to be our profile. We go to perspective. We say rotate that guy by 90. So we have it now flipped. And I'm just going to put it basically getting this midpoint here. Sorry, I have to get back out of my mid. So disable project, select your curve, move it, take the middle point on the lower edge here, and just put it basically here, and copy this guy and put it here. So now 2 things left. I want to extract again. I need a guiding curve. So in order to, I want to use the extrude method, and I'm going to show you how to do that. But for that, first we need to do an extract iso curve. Select that surface here, and now I want to go back again to U and get that, and do the same thing with this guy, and select always the middle point. That's just giving us a guiding curve, and now we can use a command which is calling it the extrude curve along curve. And again, you could use maybe a sweep, but I'm just going to use this one. And this is going to use select curve to extrude. This is going to be our profile curve in this case. And select the path near our curve. So I'm going to use this guy. And you can see now that we created this this detail here. And you can see that it's still open. It's not a closed solid. And then we can just say cap. And now it's basically capped on the ends where it was open, and we do the same thing. So extrude curve along curve, select the profile, select the guiding curve in the near of the profile, say enter, do it again if you did it wrong, like myself right here. So enter. You could actually, let's do it again. Sorry, I forgot to show you something. So you don't have to cap it. We can just say enter, and we just say solid yes. And then we select the guiding curve, and then it actually does the solid, so you don't have to do the capping. And there you go. So of course you could add some more details here and there. You could fill it anything you want at any given point. But if we go back to our rendered view, this is what we wanted to have or achieve, and this is where we got to. So if I say show, I have my starting geometry, which was this here. And actually the one that we just created looks exactly the same. So I hope that was interesting for you. I just showed you different methods how to actually get to the same kind of result using different commands. This is just the first tutorial using showing the spiral step. We will continue to use basically a normal stepping using Grasshopper as well. and just continue on with our tutorials. So thanks for watching. If you like this, please subscribe to my channel and see you in the next tutorial. Thank you very much for joining me. Bye bye.